Okay. So give me 1 sec to talk about. So I mentioned last week, which was a bit of bridge, that I'd give you more details about an upcoming exam today. So I want to try to aim to do our next exam on the 27th. So not this Thursday, but the Thursday after. Mainly because I would think would be a jerk move to do it on the 1st of November, which is the day after Halloween. Why should I ruin your Halloween evening? Maybe by making you study. So that's some other professor's job. All right. So what I'm going to do is that I'm going to go over what we're going to be doing for the rest of the semester, as well as covering like a bit of the stuff for the future exam. I'm sure some of you are like, oh my gosh, but what is this going to cover? And what form and how are we doing the format for it? So let me go ahead and let's see. Come on, GitHub. Okay, I probably have it uploaded here. Files, which I'll share, which I will share. Okay. Okay, I guess not. Oh, right, it would be documents GitHub. Okay, teaching. And ATP. Exam practice 2. So I'll probably forego anything from the Monte Carlo stuff for the 3rd exam, and focus instead primarily on the tasks of file readings, for loops, function writings, if-else statements, maybe dictionaries. I mean, since we're going over them today. But let me show you an example of something that was on an exam 2 a number of years ago, which I think is an excellent example of the kind of problem that you're going to get. At least if you're guaranteed to get a problem that's pretty much like this one. So suppose we have a file called temperature.csv, which contains the daily high and low temperatures of Philadelphia. The file is composed of 3 fields per line containing the date, the high temperature, and the low temperature. This is in Fahrenheit, obviously, otherwise we'd be dead. So each field is separated by a line of commas. For example, the contents of the file might look like this: 11, 11, 19, 64 high, 40 low, 11, 12, 19, 49 high, 21 low, et cetera, et cetera, et cetera. This doesn't go into, I'm not showing like the whole file here, because you're not supposed to make it work on one file. You're supposed to make it work on any file I give that's called temperature.csv and fits this file format. Write a program that does the following. 5 points. Sorry, that calculates or prints the following. The day finds out the day with the hottest high temperature, the day with the coldest low temperature, and the average high temperature of the entire file. So the day with the hottest high in this file with the hottest high, the day with the lowest low, and the average temperature of all the highs. So I think this is a good example of the kinds of questions that you'd be expected to do, because this covers a lot of things. It covers for loops, it covers file readings, it covers if statements, basically hits every single mark except the dictionaries and the function writing. Okay, that's kind of why I like problems like this. It hits a lot. It's kind of a realistic use case. Okay. Or similarly, another question I kind of talked about for extra practice. Here's a file. Each file has 5 numbers per line. Give me the sum of all even integers in the file. All right. I have some other ones that basically that I've been on final exams or practice final exams previously, which are un or un if a string begins with un. So these are things like making sure you know how to write functions or finish writing functions and do returns and stuff, as well as testing you on those kind of things. I'll try to keep the number of questions low because of course the time limit. But the way this is going to work is that we will be doing this exam on your computer, assuming you have one. If for some reason you don't have a computer to bring like a laptop to bring this class to code on, or you can't obtain one from like one of the kiosks, or Murphy's Law comes into effect, because of course it does, and you don't have a computer to work with, don't worry, I'll make sure to have some paper backups. Okay. But having it electronically, at least the individual portion, makes the collection of this a whole lot easier, as well as gives you more realistic resources for you to work with. So let's talk about my rules for when I do exams electronically. And I'll do this by going to the data structures course page, because I'm going to use the exact same rules as I do for data structures in this class for my exams, because it's easy to be consistent. Sorry, you know. So let's see. So build, and I'll continue to zoom in. So because I want to just get the top portion. Okay. Permissions and restrictions on the exams are as follows. Students can complete the exam on their own devices or on lab computers, in your case, kiosk computers that you can rent, you know, the ones you can kind of swipe. Students may use any coding environment of their choosing, such as, but not limited to, IntelliJ, Eclipse, NetBeans, Atom, VS Code, and Vim. Don't ask me if you can use idle. That's yes, that's included in any coding environment of your choosing. Okay. The exam is open note. The notes may be on paper, any amount of paper in any form, including printouts from the textbook. Notes can also be stored. Notes can also be notes or code stored on your computer or your personal cloud, /OneDrive, /iCloud, whatever it's called. The one that, you know, the one that you, the whatever service you use to sync files between multiple computers, you can use that. Students may access any resource on the internet that is linked from Canvas, such as my YouTube lecture videos, or my lecture recordings, or my GitHub repository, or in the case of this class, Runestone, right? Anything that's linked to anything that's on the internet that you can reach by going through my website or my Canvas page, you have access to. You cannot use resources on the internet that are not on your personal cloud, nor those that are not linked to from Canvas. This is just simply a broad way of me saying, of setting up a strict barrier, saying you can't Google the answers for these programs. Please don't try. But if you do try, you're going to get it wrong. I guarantee it. It's gonna be the many of the cases in dealing with plagiarism during COVID were people who thought they could Google one of the answers to my questions, and they ended up grabbing. It was a Monte Carlo approximation of a board game. They grabbed the wrong version of the board game because that was the first research result. You know, and it had such things as dealing with 10 pieces. Each color had 10 pieces rather than 4 pieces, like in my examples. So, you know, it's tough. I will post the practice problems when I go through them, and make sure that I only post the relevant ones, because the files over here, some of these problems aren't relevant, such as, because I want to, again, be hyper focused on what I'm doing this time for this one, which is like Monte Carlo, which again, I'll be covering that Thursday. I'll start covering that Thursday, as well as this Monopoly problem, simulating how often somebody goes to jail by rolling doubles in Monopoly, which is a thing in Monopoly. If you roll a double, you get an extra roll. If you get 2 doubles, you get yet another extra roll. If you get 3 doubles, you go directly to jail. So how often does that happen? I mean, you can calculate that statistically, but more than that, because it's 3 in a row. But I mean, we could calculate that statistically, but the point of Monte Carlo, as you will be seeing in the next lecture, is that that's hard. statistics are hard. That's why we have an entire class for it. So instead, why do that? And instead, actually like try coding up the simulation instead and count the results like 100,000 times. That'll be good. Now, notice for a lot of these questions, I have like a rubric. Now, for instance, for this question I just described that you're not getting because it's Monte Carlo, it has a breakdown of the 20 points for this question. Simulating 100,000 dice rolls, handling doubles, handling 2 and 3 doubles in a row, presenting the data in percentages. These rubrics will also act as guides as to how to solve these problems. So for instance, for a problem like this first problem that I introduced you to, which was the file reading question, I'll probably break that down into a bit more, like saying, hey, here's how many points you get for reading a file. Here's how many points you get for being able to differentiate between the different data fields, where I'll be very careful about the words I use because I don't want to say splitting it up, because that would tell you, hey, you got to use the split function, hint, hint, right? So those kind of things are, but definitely expect a question like this where you're expected to parse some kind of CSV file, which again is a comma separated value file. All right. So I'm going to try to release this. I'm sorry, the practice exam will be released next Thursday because I always like to give you at least a week's of heads up time for the practice exam. Now with that, I also want to go over what else we have for the rest of the semester, because I'm sure like you're now, you have a huge amount of homework barreling down on you. The good news is that for my class, you're almost done with your homework. So let's go to our assignments. Okay. Because once we get into the final project, we stop doing our homework and just focus on your final project, which again is a lot more freeform. So over here we have, we had the hurricane tracker due yesterday. If you didn't turn it in when you can, please, because that's a very important like milestone to get that done. If you're having trouble with it, please schedule, shoot me an email. I'm basically open anytime after noon tomorrow. That hasn't already been taken, which is a lot of time. Similarly, a Hawaiian pronunciation lab, that one is all about doing dictionaries. If you're having trouble with that one, again, let me know. The pig lab has notably been, which is worth 200 points, has notably been something that students have struggled with in the past. It's an 8-part problem. I will be doing the first few parts with you in class to make sure that you really understand kind of how it works. This really builds up on the Monte Carlo approximation, as well as writing methods and learning how to really reuse your code. After that, so come November 2nd, the homework becomes all final project stuff, which is, we have these other things that I have classified as assignments, but they're more milestones for people who don't necessarily know what they want to do as final projects. So the final project over here, November 4th will be brainstorm, is when your brainstorming is due. So that's what the proposal and GitHub lab. So what I'll be doing is that all that requires is you filling out a brainstorm form that I have, which is very short, which is basically, hey, what are ideas that you have for your final project? Okay. And then writing them down and uploading them to GitHub. I'll do an entire lecture on GitHub. Yes. What? So the final project can be a group project if you want it, and a solo project if you want that, because I know some people love group works and some people hate group work. I know what I hated with group work, and that was getting sorted into a group I had no control over. Because in college, at least, I was super shy. The date for the exam is the 27th. All right, so November 4th will be when basically the first phase of the project is due. And that's not a very hard phase. It's just learning how to use a website, which is GitHub, which I'll do an entire lecture of. It's very valuable to know. And part of that is because I don't want any dog ate my homework kind of excuses for the end of semester where your computer crashed. That's not going to be an excuse in this semester. Your computer crashed, great. Your code's on GitHub. Go get it. So the Now, if you need help securing the computer, that is something I will that's different, and I can help you out with. But you will be put working. You will want to put your code on GitHub and commit it every once in a while. So November 8th is when you will have officially chosen. Is when I want you to officially choose your actual final project. So you'll have a brainstorming session. That'll be due, and then after that is your actual proposal, which again is a form you fill out. That is due on a Tuesday evening, and the reason for that is that I'm going to spend that entire Tuesday meeting with each and every one of you to basically listen to what you plan on submitting for that, so that I can kind of okay the idea and make sure that it's a good idea or it doesn't need some work. Okay. Once you get back from fall break, you'll have the progress report. That will be due 1 week from the end of the semester. Just simply saying, and all that is a form that says, again, all these 3 assignments here are forms that basically saying, what do we think we're going to do? Okay, here's what we're going to do. And then the progress report says, hey, I'm doing it, or hey, I'm having trouble doing it, and I need to adjust expectations. Okay, that's what the progress report is. Okay. There's only 2 ways to really fail this. Okay, 3 ways. 1, don't turn something in. Easy way to fail the final project. 2, cheat. Okay, copy your final project from something online. I'll find it, and I mean like just straight copy. You'll see that I'll encourage you in some places. I will encourage you to like use other things as starting points, but you need to also tell me like clearly what you want to do to expand on that. And the 3rd way to fail is that if you haven't turned in a proposal somehow by the time we get to the progress report, I'm just going to 0 you automatically because you're too far behind at that point. Okay. Yes. It will be on GitHub if you forget to submit it. So, and then your final project's due December 7th. You may want to work over, December 5th, which is last day of classes. You may want to look over like the requirements for here. I'll probably touch them up a bit, but the idea here is that it is include anything else you want to say, such as the difficulties you faced or overcome, things you learned, what you enjoyed. We are interested in the challenges you encountered in coding and if you found a way to overcome them or not. We understand it may not be possible to complete your original vision. We are interested in how you responded in the face of adversity. We are interested in the journey, not this destination. The guidelines for an A on the final project is that it amuses me for a minute, it amazes me, or makes a positive impact in the world, no matter how small. I am easily amused. Okay. So, generally, if you submit something and show that it will get, and you showed that you put effort in, even if like it's even though it might feel like a dumpster file, it'll probably get a C, as long as you've like actually shown that you've been doing work. Because you are not doing a startup here. You are doing a final project. You are jumping into the deep end of the pool, and I'm just trying to show you actually know how to swim. Okay. That's the point of this. Now, with regards to what if you don't know what kind of final project to do, you'll see that we have a module 11, choose your own adventure. In here, where if you feel like that the world is just too big in computer science to figure out what you want to do, which it is, it's huge. I have 3 predefined kind of ideas for you to go down, which I've blatantly stolen from this Harvard CS50 X website, where I also got the final project idea from. You can go down a track for writing games in Lua, which is a programming language. These are videos that show you how to use Lua to build Pong and then Mario, and then you can use those at the starting as basically the point at which to complete your project. You can do mobile development, which are videos on how you can program an app for Android or iOS, right? Showing you how to basically do a kind of Pokédex program, an Instagram clone, or a note-taking program, and they build up to each other. is the idea. Or how do you build a website? And not just any web page, but a reactive web page, one that basically remembers stuff. Okay, so those are kind of three different ways that if you need help to know, if you're not sure where to go, choose one. But again, like, use it as an excuse to learn things that you want. And again, that's still due a couple weeks off. You know, even the brainstorming is a few weeks off. So, but now would be the time to like just kind of just think and like also maybe find people you want to work with. Okay, or if you want to work alone. I do expect a bit more out of people who do go into groups together, right? More people, bit of a higher expectation because you've got more eyes on the project to fix bugs. But again, I'm not like, this should be fun, but not like completely stressful. I have no idea about Roblox. So, but the idea so anyway, so let's go ahead and just before I dive into our content about dictionaries, any questions? All right. So dictionary, so I'm going to repeat what I've said in the videos and the lectures because I think it's important enough to go over a few times. Okay. Dictionaries are also called associative arrays. They're also called hash maps or hash tables in other programming language. You'll learn, they essentially allow for on a, so in the really abstract beyond this class is need to know level, these are constructs, these are data structures that work in constant time, insertion, deletion, and retrieval, and which is kind of magical, but they waste a lot of space. What does that mean? It means they're very fast when it comes to seeing if something's in a if something is in dictionary. Dictionaries are declared using the following. As we showed during the Roman numeral lab, we use curly braces to declare whether or not we have dictionaries. Typically, I'll refer to it as D, dictionary D. And we went over about how they basically differ from lists by not having indexes, right? You don't just simply say D. It doesn't have any indexes predefined. You don't append to it. Right? You don't append to it. That doesn't work. You have to say, here's a key value binding. Now, this is a very abstract way of doing it. So what are some concrete uses for this? The concrete uses for a dictionary. First, the most common thing you'll use it for in an intro to programming context is counting, which is what I'll be using it for today and what I've done in videos in the past, which is counting arbitrary things. So say you want to count how many things say you've got some text and you want to count how often each letter occurs in the text. Well, that's all fine and dandy until, because we can figure out, okay, so without a dictionary, what would I have to do? I'd have to have a list and I'd have to say, okay, 0 is A. I'll use index 0 to count the A's, index 1 to count the B's, index 2 to count the C's, index 3 to count the, and I'd have to do some mental, math to remember that all. There's actually some actual math we can do using the value of the numerical value of characters to make that easier for us, but I digress. But that's just it's a pain, but we can do it. Okay, but that's letters. But what if I gave you a document like our Dracula text, and I said, okay, I want to know what the most common 10 words in the book are. The most common 10 words, or just even the most common word in the book is. And in order to do that, you'd have to keep track of all of the words and how often we see them. This is what dictionaries are built for, where we use the key, for instance, to be the word that we're counting, or one of the words we are counting, and the value to be how many times I've seen it so far. And when I see it again, I just increment it. Oh, I just saw Dracula. I just saw the word Dracula again. I better say that is one more than I previously saw it. Right? So counting when you don't know when you don't necessarily know all the kind of things you will be counting. That's what one use for dictionaries. Another good use for dictionaries, which you'll see not as often, is categorization, where basically the key represents the category and the value is the list of all the things beginning in this category. Typically, you'll know what your categories are because you have to know what your categories are in order to sort things into categories. So for instance, say you wanted to sort things in based on their part of speech. You could just simply sort them into like, okay, like this, so D. We would say D of adjective is equal to an empty list. And then when I find an adjective, whoops. And when I find an adjective that went over beyond the end of the page, that's funny. When we find an adjective, what we'll do is that we will say, oh, here's an adjective like somber, because again, Dracula. We'll just simply append it to the list that is matching that. Right. The third use for this is straight up key value mapping, where basically we are saying, okay, I want to log into a system, or a user wants to log into a system. All right, say you come to an advisor. Okay, what does an advisor typically ask you for so they can pull up your record? Yep, not your name. Your name, it's wonderful, but it isn't unique, unfortunately. I probably told you this, but went to a middle school and somebody had graduated the previous year. They had the same name as me. And I kept getting questions. Are you related? Is he your brother? Well, why would a family name the same kid the same name? I don't know. Anyway, but the point being is that you use a unique identifier. Like on Amazon, that's your email address. Or on other websites, it's your username, right? Something that can be uniquely identified to you and only you. And then it pulls up all your other data that's related to you, like what's in your shopping cart, for the case of Amazon, as well as your other details, like your non-unique details, like your name and address. Your address isn't unique. You could live with somebody. In terms of and this is especially important in terms of advising, because you definitely want to make sure you're pulling up the right students' grades and stuff. So we use QID to make sure we get your name and everything about you. Okay, so how would I use this to say to count things? Because in an exam, and I think I've had this reserved for exam 3 last time. Exam practice 3, let's see this. Let's see. No. Let's see. That's regular expression problems for a lot of the parts. A lot of regular expression stuff. Yeah. No, okay, don't have an example problem here to give you, but an example problem would be a lot of times, hey, I give you a string, please give me counting all the words. So let's go ahead and do that. Let's create a file. I'm gonna call it drac count. Because we'll be counting how often Dracula appears. Oh, wait, no, that's not what I want to do. New file. There we go. Save. Drac count. Okay. Yes, I know I have multiple files open. Hush you. All right. So again, let's go ahead and open. And let's see. Do I have Dracula still here? No, I do not. So let's go ahead and I will grab. Oh, that's why. Let me move the location to teaching to be data structures, not data GitHub classroom. Okay. All files. Yeah. Actually, well, I don't have. Let's see. What do I have in here? What do I have? I'm just seeing what files I already have. All right. I can go ahead and grab Dracula. That's fine. So I'll go ahead and grab Dracula again. Go to Project Gutenberg. Dracula's book 345, and I will go ahead and download this plain text. Let's see. And GitHub. Mushroom. And Dracula. All right, so I'll go down there. You can use any file, text file for this, but I'll be using Dracula. Okay, and the first thing we want to do for open, and again, what I'm trying to do is find like the most common words in this. So in order to do that, I've got to do a word count. So I'll open Dracula.txt. And I know that Dracula on Windows, at least, I get something weird if I don't do this, where I have to say encoding is equal to, I think, UTF-8, all underscore like that. Sorry, all like that. There's a couple different ways. Let me test it. Yeah, okay, that worked. Okay. So I'll open Dracula using the read. And this is just some magic I have to do because I know the way Dracula works on my computer. We covered that a couple lectures ago. Equals, whoops, assuming I type in the right place. Okay. Data is equal to this. And then we want, we'll call this our count is equal to this because we'll be using this. This is going to be, we'll create a dictionary called count, which we're going to use to count our words. Okay. And what I'm going to do is that I will go through this file of Dracula one word at a time. And as I see the word, I'll add it to the dictionary. Okay. So first, let's go and iterate through the Dracula file. That's our first step. So let's go ahead and just do text is equal to, I could do either data.read or data.read lines. It doesn't matter. Today, I think I'll do read lines. Let's see. Or, now I'll do read it myself. Text is equal to data.read. And then I will do, I'll just read it. I'll just read the file all at once. And I can print it out. That's all you have to do to read a file in actuality in Python. And it should like tell me, hey, we compressed a huge amount of output because that was a big file. Like, yeah, I don't want to squeeze. It's like, hey, you've got 15,000 lines. Do you really want me to print them all out? Yes. Sorry. So what read does is that it takes the entire thing, it takes, one second, all of this file over here, which is Dracula. Okay, it takes all Dracula, okay, and it stores it as just one ginormous string, just one big string. On the other hand, what read lines does is that each thing puts it in a list, and each item in the list is a line of text. So this would be one line, this would be another line, this would be another line, another item in the list, another item in the list. So instead you're dealing with multiple strings. And they're both good ways to do things, especially if you know you're going line by line. In fact, that might be a better way to do that. So we'll go ahead and do lines over here. Just to show you lines. And print lines. And we'll see that how this works. now. And yes, it takes a while because, believe it or not, some text files take a bit of time. Yes, I'll open it. I know it's going to be dumb. So there it goes. It says, hey, here's the start of that /UFEFF, the Project Gutenberg ebook of Dracula by Bram Stoker. And so notice that basically it's just split up each of these into a line, each line into its own kind of file. And my idle is apparently crying for processing power because it is not meant to scroll over these large files in its output and try to figure out how to make strings out of them and that kind of stuff. Poor idle. Yes, I know it's not responding. That's fine. Open recent file, Dracula count, and we're back. All right. So now that we've got lines of text, we want to kind of split it up word by word, right? That's kind of the idea here. So let's go ahead and make the easy but faulty assumption. Okay, the easy but faulty assumption that we can just simply split it up by that we can say that words are separated by spaces. So what we can do is we can say for line in lines, line dot split. We know that line is a string, and let's just go ahead and just review what split does. Dot split returns a list of words in the string using separator as the delimiter. So if we try that, for instance, over here, hello, comma, world, how are you, right? Just a reminder of split. I know a lot of you already know how to use this. But if I run it, it'll split it up into hello, world, how are you? Now notice it doesn't take care of the punctuation or extra spaces. But it does, actually, does it have an extra space? No. Doesn't take care of punctuation. Let's go ahead and see if it takes care of extra spaces without any parameters. Let's see, hello world. How are you? So just using split, we'll basically split it along white space, which is your new lines and your tabs and your spaces. So using split without any parameters seems like a good starting point. Yes, we're going to have to deal with punctuation eventually, but we'll leave that as a problem for a week or two from now when we cover regular expressions where that becomes really useful. Okay. So, or really easy to do. So what we'll do over here is that we say, hey, the word, so for each line in the lines, we'll split it up each line into words by using the split function. Okay. And then the words is a list of words, and we'll say for word. So let's see, for word in, actually, let me go ahead and just print this out. And I'm not going to print just so we can see them intermediary progress. Words. And we don't want to go through all the lines of Dracula. That's a lot. So I'll do lines 200 to 220, 210. Just 10 basic lines out there. Okay. Oh, sorry. Oh, okay. Proper being assisted by famine and disease. And we can see now that we've gotten that it is splitting it up, that words is a list of strings where each string is an individual word. And that took so long because I forgot to comment this part out where we print the text. Don't want to do that. We run it now, much quicker. Okay, boom, boom. There we go. Make sense to everybody so far? Now what we do is that we're going to go through each of these words individually. For word in words, print the word, individual word. So if we do this, we see that we've got that we're at least we're at least finding individual words. Now we do have some issues with punctuation, but we can deal with that later. There's a couple different clever ways we can deal with that later. For right now, don't worry about that. Right now, what we see is that we are interacting with this now one word at a time by splitting it up into lines. Then for each line, we split it up into words. And then for each word, now we can start using our dictionary to count each word. And the way we do it is surprisingly simple to count a word. So for every word that I'm trying to look at, I want to ask myself, if word in count, have I counted this word yet? Or let's actually start it. Have I not counted the word yet? This is a bit easier to understand if I do it this way. So if word not in count. In other words, is this word one of the words I've seen yet? Is it one of the keys? Is it one of the words I want to count? Okay, well, it is one of the words I want to count, but have I counted it yet? If I haven't, how many times have I seen it now? Once. So we say count of that word is equal to 1. Otherwise, the else here is that it's already there, right? So I've already seen it. So I would say count of word plus equals 1. That's all you have to do to actually do that physical counting. It's just an if-else statement. If I've seen it before, increase the amount of times I've seen it. If I haven't seen it, well, I've seen it once now, so it's that value. So let's go ahead and print the end result of that, and then I'll go through it. So print the count of Dracula. Yes, the entire point was a pun. Okay, and we see that in those 10 lines, we found the word the 5 times, and to appeared 5 times, and of 4 times, and dress white. Again, we're dealing with some issues there. Peasant appeared once. So also notice that there's really not much kind of coherence in the order that words will appear. It's just part and parcel of dealing with dictionaries. Well, actually, they'll appear in the order in which they were inserted, I believe. But don't read too much into it, is the point. It doesn't work that way in other languages. Okay, so for each word, if it's not there, I've seen it once. Otherwise, I increment the number of times I've seen it by once, right? So let's go ahead and for instance, let's go ahead and see how this works, progress-wise. Print. So if I find a word that I haven't seen before, I'll say new word. Sorry, I'll print out new word. And then I will, I'll assign it. And I'll print out the new word, and then I'll print out the dictionary, the count, and then I'll print out a visual barrier to help sort between the various printouts that we're getting. All right. And now we can scroll up, and we'll see that basically the first word in those is that it finds proper, being, then assisted, by, then it finds famine and disease, Count Dracula, directed me to go. And then over here, when we find our first the, we'll see that we also found a to before we hit the new, in between getting to the, to go to the, and then we've got And so that got incremented to 2 because there was a 2 in between the and go. And we'll see that basically that it increases, and as we see more 2s, we increase 2. So now let's go ahead and work on this over the entire file rather than just a small part of it. And we should get some interesting results. Assuming I print them out, actually, which is always the issue. Print, count. So now we can print out our results. Oops. And we'll now actually do the entire file. And we'll see that it becomes a very, very large dictionary with capital YOU occurring 144 times. It with a comma after it occurring 137. So there's a lot of kind of refinement we can go on. Now, getting to this to being getting at the point where we're saying, okay, let's do this in getting to the point where we're saying, okay, let me go ahead and find what the 10 most common words in here are. That's going to take a bit of going, but let's go ahead and open up nope, that is the different file. Okay, GitHub, right, Classroom. I'm going to open up in VS Code because it handles this kind of stuff better. And I'm just opening it up in a different editor. So joink. So there we go. So run it. And there we go. And so we see that we've got soundly appears 5 times, wakened appears 5 times. And it's not really in any kind of useful order for us in terms of sorting, but there's some other things we want to take care of first. A bit of sanitizing of our strings first. So first thing we want to do is that we're dealing with, capital letters and lowercase letters all over the place. So let's go ahead and make words just be lowercase. So word is equal to word dot lower. I believe that's how we do it. No? Or is it too lower? No, it's lower. Okay. The linter finally caught up. Okay. Next is dealing with that weird hanging, punctuation mark at the end, right? That was kind of weird. So there's some ways to deal with it, but we've only really, because of the way we're splitting on these lines, we're really only going to find the punctuation mark at the end, right? Comma, period, question mark, exclamation point. So we can ask ourselves if word dot, so if the last thing in the word is one of these things, so if it's in, let's go with period, comma, question mark, exclamation point, dash, anything else anybody can think of? Keep it there. Then in that case, we'll say word is equal to word everything but the last character. Going up to, but not including the last character. And now when we run it, we get a lot more. It gets a bit better. There's some stuff here that's a bit weird, but some of that's also the clerical stuff that's been added to the file. You get some stuff like this where we've got the original stroke being added. It's a bit of an annoying thing. Let's go ahead and seeing if word is equal to word dot strip will help deal with that. Should, or rather, it should have already been taken care of, but No, it didn't take care of it. Oh well. It's a losing battle right now and not really worth it. But the point being is that you can go and sanitize some text. Sanitizing is hard without regular expressions, which we will learn because they're super useful. But this is really all it takes to use that dictionary to count files. So the issue is, how do we find the most common files? Oh, sorry, the most common words in this. And the answer is that it's actually a bit of a pain to sort dictionaries, but because when we want to sort them, we typically want to, how are we going to sort them? Well, so first off, there's a sort function, or rather there is a sorted function, I should say. And if we print that out, it's not necessarily what we'd expect, I think. It sorts everything in alphabetical order. Kind of gets to a point where it just stop, where when we get to the regular words, it goes through and it says, okay, I printed out a long enough line, I'm done now. That's the way some consoles work. Okay, so sorting it would just simply give us all the keys that have been sorted. Okay, so but sorted is otherwise pretty useful. The other way to go through it, though, is to do something like this. Sorted key is equal to, let's see, sorted count key is equal to count dot values. Dictionary values takes, oh, no argument given. So what do I want to provide it? I always forget how to do this. Values. Like, it's something that I have to look up every single time, so don't feel bad if you have to look it up too. Yeah, makes sense. Not callable. Okay. And watch how to sort dictionaries by value. And in other words, the value being the numbers that we've counted them by. Key item. Sorted item. Hey, you sure there's not a way to deal with them using, oh, there we go. .get. Okay. That makes sense. That's what I wanted. We didn't want lambda. Lambda is a bit much. I know you can do it without lambda. So sorted count over count.get. Now which is the function. Now it's saying to use the get function to sort them. Let's see. Oh, right. Didn't print anything. Of course. All right. And now what it's doing is that it is sorting the words from the least amount of time we've seen it, sorry, the least amount of times we've seen them to the most amount of times we've seen them. Okay. So so there's one more thing we add to do that, which is get, and then reverse equals true, which I only remember because it's telling me how to do it as I'm typing it. So I probably wouldn't ask you in the exam what the 10 most common words were, because it's a bit of a pain to do, as you can see, but they are the, and, I, to, of, in, he, that, it, was, and you can see. So can we actually get some useful data out of that? Well, yes, the sorted is something that we can iterate over. So we say for for word in this thing, and this is basically, again, the only thing that I had to look up, and so don't feel bad about having to look at this up. It's one of those more annoying things to have to do in Python, but so if the word is in, so for each of these words, I want to print out the word and the count of that word. And last thing, let's just do the top 20 of them, because otherwise it's going to be unscrollable. So top 20 words that appear in Count Dracula. Let's see, come on. But the count 20, I thought it was top 20. Apparently not. Weird. Let's see. Why wouldn't it be? That is very interesting. Oh, I must have hit it. Okay. I must have hit the F5 before I put the 20 in. Okay, there. The top 20 most common words are the and I, two of in, he, that is, was, as, for, is, we, his, not, you, with. So that is how often those words, would end up. Now, is this a question I would ask you on an exam about dictionaries? No. What I might ask you is something along the lines of write a function that prints out how many times Dracula occurs, or count and Dracula, or the like. Or I'll just tell you to do a word count. So everything basically above line 18. Does this make sense to people, or I lost people? Yeah. Yes. So again, I'm sure this is similar to something I've done on the videos, but dictionaries are super useful. They're all, and as we'll see with doing our Monte Carlo approximations, this is going to be super useful for doing for figuring out outcomes, statistical outcomes, because you don't necessarily know what the statistical outcomes are going to, what your results are going to be, and you don't want to have to pre-program them in, so you add them as you go along. So for instance, let's say that you are doing a program that say you're doing a bit of Dungeons and Dragons, for instance. Anybody play that, Dungeons and Dragons? Yeah, one person. Great. This is going to be a very easy to appreciate the example. I'm sure some of you are just being shy and not raising your hand. But the game revolves around a mechanic which is rolling a 20-sided die. I think that's a dodecahedron. So, and basically your success and failure are determined on the random outcomes of a die roll. Well, we could track those outcomes using a dictionary. Since not too many people are familiar with that, let's think about, let's see. I'm trying to think about another relevant example. Ah, yes. Let's see. Do I have it still here? No. Okay. Well, in that case, let's go ahead and go back to that practice exam, because it does have an example there to lead us into Monte Carlo approximations. So, I'll lead this off by saying that that I am a bit of a trickster. If you haven't picked that up, I enjoy questions that are tricky, and I enjoy games of chance that are completely rigged. So for instance, there's different paradoxes, and you'll want to watch these 3 short videos that are not by me for tomorrow. Specifically, this video, not tomorrow, for Thursday. Specifically, this one on the Monty Hall problem in which is done by Numberphile, which is one of the most controversial math problems to ever come out because it just generated a lot of controversy when it did. This video of how Monte Carlo approximation might work with by dropping a ball, and then this one by was it Mark Roper, it's the guy who's built the the porch pirates stink bombs, essentially. Great engineering project right there. But he also does a lot of other engineering projects, and here he does a analysis of various carnival games. And there's some things that you just don't know how often you're going to win or lose. Like, how do you calculate how often somebody is going to basically be able to get to the end of this weird rope kind of game, or what is the average amount of points that somebody's going to shoot in one of those carnival games, in one of those carnival basketball games. Those things are very hard to quantify with statistics, but what you can do, and what he does do, is that you can pay a bunch of friends in churros to go and sit by these games and count how many people win. And that's basically all Monte Carlo approximation is. So one of those problems that one example of a Monte Carlo approximation I've given on exams is the one that and this is more for exam 3, but a lot of the techniques you use here are valuable. So I'll open it. It's a good segue. So let's see, teaching. Sorry, I got through that a lot quicker than I thought I was. So exam 2 practice. So one of the problems that won't be on exam 2, something that will probably be on the exam 3, which again is the idea of this Monopoly game. Now, if you're American, you probably dealt with dealt with Monopoly at some point. If you're not American, I can't speak to that because I don't know what the status and popularity to board games outside this country is. But Monopoly is known universally for 2 things, which is that the games take forever because nobody actually plays by the actual rules of Monopoly. They just make up the rules and without ever reading the actual rule book. It's kind of hilarious because the game is all about finding an early winner who runs away and basically establishes complete dominance that can't be escaped from. A Monopoly. So in the board game Monopoly, the players will move around the board by rolling a pair of 6-sided dice and then buying a property and attempt to bankrupt each other. Only the dice rolling part is relevant to our thing, rolling 6-sided dice, because rolling a double, which is rolling 2, right? We're rolling 2 dice here, rolling 2 dice and having them come up with the same face. So rolling 2 3s or 2 4s or 2 5s or 2 6s. It's great because that essentially allows you to roll again. And then if a player rolls a second set of doubles, yet another extra roll, 3 doubles, right? I explained this at the beginning of class. Go directly to jail. So Monte Carlo, so the odds are actually able to be calculated here, but the idea here is that we can calculate that by doing a Monte Carlo approximation. And this ties into dictionaries because we can use dictionaries to kind of track the outputs. For instance, how common is it that we get certain combinations, right? We could ask ourselves, for instance, like this. Well, first, let's go ahead and import random. And then we will do ITP dot. Okay. Import random. No, I said .py, I thought. Not a text file, .py. So import random. We can use dictionaries to count our outcomes. So for instance, we have I'm going to use a notation that is useful for dice. So I'm going to call it roll d6, where d6 stands for six-sided die. And this generates a random number between 1 and 6, right? So how do I generate a random number between 1 and 6? You may have forgotten, but it's random. The randint 1, and random is the only time where we do inclusive brackets, where it includes the both sides of it, A and B. So this will generate a random number between 1 and 6. Now, what's important to understand is that these are rolling 2 dice are 2 independent events. I can't just simply roll the d6 and multiply it by 2. These are 2 independent events. Yes. Random number generation is like the only time in programming languages where the end is included as opposed to excluded. It's weird. I know, it's like the one time we decide to break the rule. But if you check the documentation as it comes up, it'll say return random integer in the range A, B, including both endpoints. So to roll a six-sided die, right, then we can just simply generate a number by saying roll d6. And I actually should probably call it, because otherwise I'm just going to get saying, hey, it's a function. Okay, and now I actually have to return my value. So now 2, and if I run it again, I'll get a 2, and I'll get a 3. So I get random values each time I check, randomly distributed values each time I call it. And I can, keep track of my outcomes in a dictionary. Like this. Outcomes is equal to a dictionary. And then what I can say is for in range, let's do 1,000 dice rolls. We'll go ahead and say roll is equal to the outcome of rolling a d6, and say if roll in outcomes then outcomes of that roll, we've seen that before, so add 1. Otherwise, we haven't seen it before. So we do that. So we say 1. And then we can print our outcomes. And so even though we don't, our outcomes doesn't even know it's getting the values 1 through 6. I mean, that's what happens. We get the values 1 through 6 here. We get 2. So, we got 162, 2 rolls, 148, 3 rolls, 172, 5 rolls. And that may not seem like completely evenly distributed, but it's close. I mean, the more we do, the more rolls you do, the more we see that they're basically close to the same identical value. Around 16,000, 1 and 6. Now, when we're rolling 2 6-sided dice, those 2, you can't just, again, multiply by 2. What we would have to do is something along the lines of this. Roll another 1d6 and then call the function to roll another dice, because they're 2 independent dice. Make sense to everybody? And that gives us a much more interesting spread of results, where its numbers are no longer evenly distributed, right? Because we all know, just at least from playing games, that if you're rolling 2 dice, the 2 1s come out, rolling a 2 is much more uncommon than rolling one of those middle values, because there's only one way to roll a 2, And that's by getting ones on both of them. Right? And we don't get the ability to, and the values go from 2, because again, the minimum, we've got 2 dice, minimum value of 1 on both dice, and to 12, maximum value of 6. You can't roll a 7 on a dice unless you're an expert swordsman and got a really clean cut. So, so again, if we wanted it to be, look a bit cleaner, we could say, hey, print sorted. And here we'd want to sort by the key. So sorted, for outcome in sorted outcomes. So again, sorted is useful when you want to sort something. By default, it's going to sort it by the key. And if you have to sort it by the value, things get a bit weird. So for outcome in sorted, what do we want to do? We want to print the outcome, and then outcome, this is a bit weird, outcomes, that particular outcome that we rolled. Yeah, so why don't we change that from for value in outcome, print the value and the number of times that value occurred as an outcome. And then we'll be able to see over here that we get our, okay, interesting, that we get our bell curve distribution here. So, and as you can see, the 2s and the 12s occur basically equally as likely. So again, dictionaries are kind of useful because we can just use them to keep track of stuff. Now, in your homework about for the Hawaiian punctuation, dictionaries are useful there for translation. Amazing that. Where we can say, okay, this pair of letters goes to this pair of letters. Sorry, it goes to this sound. So for instance, like you might want in your Hawaiian pronunciation lab, you might want a dictionary for double vowels. Such as like this. And then you can populate it in line, like saying, hey, the AI, the AI combination goes to I. And let's see, another one would be EI goes to A. And so having a dictionary set up for your double vowels and having one set up for your normal vowels will be very useful, because you can then ask yourself, hey, is this 2-letter pair, is this 2-letter slice inside double vowels? You can ask if this is some letter pair in double vowels. If it is, then you can translate it directly. If it isn't, you can just simply go on to the next category, single vowels, and then consonants. Okay. My other hint for the Hawaiian lab, by the way, is that part of working with the Hawaiian lab is that you might think you have to worry about going out of bounds, because you have to look to the left or look to the right, look to the character one index to left, so a negative index, -1, or an index to the right, which is +1. But if you use slices, interesting note about Python, slices never go out of bounds. It's a weird quirk that I fully encourage you to exploit with Python. For instance, if I say hello, and I want the slice of hello to 3, all the way up to this ridiculous index, Slices don't go out of bounds. They'll just simply go as far as they can and then they'll stop. Don't know why they made that design choice. Exploit it for your homework. All right. So if you did not get your exam, please come down if you want me to try to look for it. Have a good day.